Burleson, Texas. This is a Mission 13 flight experiment.
Hello everyone, we are a team from Burleson ISD, Burleson, Texas. My name is Heston Irons, and our additional co-investigators are Ashlyn Johns, Caroline Harvey, and Sohan Islam. Sarah Kateris Cortazar is also a co-investigator, but was not able to be here today with us. We are all sixth graders from STEAM Middle School of Choice, and our teacher facilitator is Mrs. Sanchez. Our question is, what are the effects of microgravity on the growth of Eisenia foetida earthworms, or red wigglers? We chose earthworms as our experiment because we're interested in decomposers and whether or not we can use their benefits in microgravity and on other plants with reduced gravity. We also chose red wigglers because there are specific attributes. They are small, many worms hatch from one cocoon, they thrive in the shallow, dark places with only a small amount of moisture needed. And they can live in an environment similar to the FME mini lab. We think decomposers can help us grow vegetation outside of Earth's atmosphere and can only help future explorers.
Our experiment is meant to compare the growth of Eisenia foetida or red wiggler earthworms in microgravity versus Earth's gravity. We're going to put specific things in our Type 3 FME mini lab. We will need the cocoa coir brick to absorb water because we want to have a moist environment for the earthworms. We also have purina worm chow so that when the earthworms hatch, they will have the food they need. We have organic material bedding to stimulate earth soil. The formalin is a fixative to stop the growth of the earthworms so that we can measure and compare the growth of the earthworms in both microgravity and Earth's gravity. We will put the earthworms in a state of hibernation by refrigerating them, which will slow their development. This is a critical fact we observed during our trial runs. We wanted to make sure the earthworms didn't hatch until they were in the environment of microgravity. But this can also create a potential problem of fewer hatchlings, so we created a color guide to show the color change of the cocoons. If some of the earthworms are not completely hatched, then we can at least see the progress of their growth within the cocoon by the color.
First, we are going to cut open the FME tube from Earth, and then cut open the tube from the flight experiment. We use an X-Acto knife to cut open the tube so we can access the worms. We will take the total weights of all materials in each FME tube to record the data. Next, we will separate the worms from hatched worms and unhatched worms. If the worms are large enough, we use tweezers, but if they are too small, we will use a pointer to sort the worms from hatched and unhatched worms. For the unhatched worms, earthworms, this color scale is necessary to show the growth instead of simply counting the hatchlings. It will collect the data compared to the color change scale. In our previous trials, we noticed hibernation stunted the hatchlings, but the cocoons continue to change color, which is an indicator of growth within the cocoon. After sorting, we will compare the length of red wigglers from Earth's gravity and microgravity by measuring with a ruler. If the average length of the flight experiment worm is less than the average length of the earthworms, then that would show individual worm growth is inhibited in space. However, if a greater number of smaller worms can exist in space, they could possibly do an equal job of decomposing than larger but fewer worms on Earth. Overall, the higher average of length or number of hatched earthworms equals a better growth environment for the Eisenia foetida or red wiggler earthworms.
We predict that the red wigglers will grow the same rate on Earth as in microgravity. The reason we predict this is because the FME mini lab is pretty much the same environment as a normal Earth environment in terms of light levels and shallow soil. We think the soil will adhere to the sides of the mini lab because of the moisture content and the adhesive quality of water. The hatchlings will be able to move through the soil normally. For our next steps, we would like to study earthworm reproduction to see if they are able to reproduce in microgravity. If they can reproduce well in microgravity, then we would like to use them as model organisms to study on other organisms also. We'd like to thank Ms. Sanchez, our teacher facilitator, Ms. Hughes, our district SSEP coordinator, Chris Rogers from Buckeye Organics, our earthworm provider, Burleson ISD, and the Academic Innovations Department, STEAM Middle School, Nanorex, Texas Christian University, and SSEP. Thank you for your time.
Do we have any questions for this team?
I have a question. How'd you come up with the idea of earthworms, to use or make the project about that?
So we knew that they were small and they could live in like very confined small spaces and they needed to be very moist and they don't really move around a lot. And the worm that we chose just moves, it doesn't move vertically or diagonally, it moves just in a straight cross line. So that's why we chose an earthworm.
Okay, thank you.